Yes, ma'am.
Oh. Is my screen visible to all?
Yes, ma'am.
Okay, so let's get started. So in our previous class, we were talking about the NumPy. So as I said, NumPy is used for advanced mathematical computations. So with NumPy, we have seen the array data type, and we have seen how to create, how to access, and how to do the processing with the NumPy arrays, right? And the file is also done, how we could save the NumPy arrays to file and how we could load the same. Is that fine? Clear with NumPy? Yes? Fine or
Yes,
not?
ma'am. Yes,
Oh,
ma'am.
okay. So today, let's talk about the pandas, the module pandas, or you can say the package pandas in Python. So pandas, it's a module that is used for managing the data. NumPy was for advanced mathematical computations. This is for managing the data. So when I say data, here you could see, as I said, the data set that we are going to handle will be in the form of CSV files, wherein the data will be arranged into rows and columns format. So Pandas module or package is being used here to manage the data. Most of the times we read the data in the form of the CSV file using the help of the Pandas module. It's because it is easy to manage our data. Suppose if you have to process any row or any column, if you have to remove any particular column, or if you have to add any new data to the frame, it's easy to go ahead with the Pandas module. So Pandas modules has lots of functions supporting to manage your data. So as I said, its main use is that this is going to create two data types for storing the data. That is, the first data type is series, and then you have the data frame. So these two data types are helping us in managing the data using the pandas. So you can think of pandas data frame like your Excel spreadsheet that is storing some data. I hope you all are familiar with Excel sheets. You know about the Excel sheets wherein the data will be stored in the form of rows and columns. Yes or no? Yes. In
Yes,
Excel
ma'am.
sheets, yeah, Excel sheets, you can see the arrangement of data in the forms of rows and columns. So let's take for example, we have the column informations like this. We have one column which has the customer name. And one column can have the product details. That is the product name, let's say. We have the product name, and the another column, let it have the price details, and then let's say we have the quantity of items that is purchased. So these are the column details that we have, and then the rows could be the individual sales, let's say customer 1 2 etc 3 etc, the individual sales. So I can say that a data frame is made up of several series. In this, each column, you can call it as a series. Each column, I will call it as a series. And I'll say that combining this series, that is the rows and columns together, is what I call as a data frame. This is together a data frame. So series, you can look at it like individual columns of your data, and data frame is nothing but the rows and columns together. So I can put like this, a data frame is made up of several series. Data frame is formed by multiple series, and each column of your data frame is a series. right? And you can name each column and row of your data frame. You can rename them, you can give them names when you are creating your data, when you're manipulating your data, etc. So similar to the NumPy arrays, a data frame is also a good data type for storing your data. It's much easier than handling with. You can also create this arrangement of data in rows and columns from using list of list. Nested list also, we can create a data with rows and columns, correct? But more easier than that is by directly using the data frame from the pandas and then manipulating your data. Manipulating your data becomes much easier if you go by the data frame from the pandas. So data frames are more flexible than NumPy arrays, we'll have to say. Right? Is that clear?
Yes, ma'am.
Yes, ma'am.
Okay. So let's see how to work with the Pandas package. So as a first step, you need to import Pandas. So import Pandas. Let me rename it as PD. Let's import NumPy also. As a first step, import these two and let me know if Pandas is supporting for you. NumPy we have already done, so that's not going to be an issue. Let's check with the Pandas.
Yes, ma'am. It's supported.
Of the series. So series are what? Each columns. So that columns I can create it by the NumPy arrays. Okay, or I can create it by using a list. For example, if I had my list, let's say the data are 5.4, then what 6.1, then say 99.8, then 3.2. I have created my list. I'll create my NumPy array as well. I'll say my array is equal to np.array, and this array, let me create it from the list. So this we have already verified in our previous session. Right? What did we do? We have created, I can say we have created a NumPy array. So to look at series, right? You can think of this as a single column of a spreadsheet, the Excel spreadsheet. As I said, the series, you could think of it as a single column of your spreadsheet. And each entry into your series corresponds to the individual rows in your spreadsheet, isn't it? Each column entry is corresponding to the individual purchases done by a particular customer, if we talk with respect to the example what we have considered. So we can create a series. The multiple ways by which we could create series is what we are going to talk about. So we can create series by converting a list or a NumPy array. So let's see how to create a series. So let me call the series. I'm calling it as my series 1 equal to, from the pandas, I will call the method series. SS capital, okay? SERIES. I'll call method series, and as an argument, I have to specify what my data is. So I will say data is equal to, let me create my series using the list. So I will give the data as the list, which we have created previously. You could display it. So let's say, if I say my series, okay, it's series 1. Can you see how they are arranged? This is the column that we have created, our list 5.1, 6.1, 99.8, 3.2. Corresponding to that, can you see these row values? 0, 1, 2, 3, the indices. Can you see that? So this is like a arrangement of data in the, like the example what we talked about. So every column, the entries in your column is corresponding to the individual let's put it like the purchase or the customer details. So every entry corresponds to a row value. So this is, we have created a series from the list. Similarly, you can create your series from the NumPy array as well. For that, what you have to do, in the place of data, you just have to say it is your NumPy array. Give your NumPy array name. So you have it as my array. After this, you can display your my series too. So can you see how series are organizing your data? Yes. Please verify your outputs. So we have created the series from the list and array. Let me know if you have verified and if you are clear with what series is. Verified? Verified or not?
Yes, ma'am.
Okay. Now let's see how we can access the elements from our series. So accessing the elements from the series is same like what we talked about the list and arrays. You can say, for example, let's display the same. Suppose if you want to access data from the series, let's call it as my series 1. So I will say my series 1 of give the index value. So if I give 2, it is accessing the element 99.8. 99.8 is present at the index 2. So please verify. If it was 0, it would have been the first element of your series.
Done.
Okay. Now you can add labels. Instead of leaving the indices like 0, 1, 2, 3, you can add labels to the series. That is, for example, let's create a labels of list. Let me name it like first, second, third, and fourth. I have created a list of labels. Now, when I'm creating my series, so pd dot series, I will say data is equal to, let me give the data as the list. And here I will add another attribute called as index. To this index, I will add my labels. Right? So now if you check the series 3, can you see the indices are now replaced with the labels, whatever you give, first, second, third, and fourth. So if you need to add labels to your series, you can add a attribute index and give the labels as a list. Please verify. Verified?
Yes, ma'am.
And when creating your series, you don't need to explicitly specify what your data, what your labels is. You can also create in this manner. If I say my series 4 is equal to pd dot series of, if you say my list, comma, labels, this is also fine. The first entry will be taken as your data and the second entry will be taken as the index. But I prefer going with the previous method because then it's avoiding all confusions. So, but yes, this method is also fine. So whichever is comfortable for you, you can go. But I usually recommend the first methods, explicitly, like implicitly specifying what your data and what your index is. But it's your choice. You can go in either methods. Both will create your series. Another thing is you can also access the entries of your series by using the labels as well. That is, if you say my series 4 of, let's say, first. This will access the value corresponding to the label first. So this is also a method of accessing the elements from your series.
Done, ma'am.
Okay. Next, let's try doing some math operations onto these series. So let's create one more series. Let me call it as series 5. So I'll say pd dot pd.series of. So the first is your data. So here you can directly give your list. If you're trying to create your series from a list, we have seen that you could create your series from a list. So you can directly give the list values here itself. So 5.5. Then let me say 1.1. What to say? 8. More value I need. Let me give 1.6. So this is my data. And then next I have to add the labels. So if I give the labels like this, give a label like any label name I can use. Okay, it need not be in order, but according to your requirement, you can create it. So let me just simply give the labels like this, fourth, and then so this is my series 5 and we have our series 4 here. So series 4 has labels first, second, third and fourth. Series 5 has labels first, third, fourth and fifth. What I'm trying to do here is I'm trying to add the two series. That is what I'm trying to do is I'm trying to add my series 4 and series 5. Let's see how this is going to behave. Let's check, is there any importance for the labels of your series? Let's see how this is going to behave. So let me just display the result. I'll say print my series 4 plus my series 5. What can you understand from this behavior? See, series are very important. This series and data frame is how your data is when we are trying to build a model. So manipulating with them is very important. So please understand everything step by step in detail. Because once we are starting to build a model, I told you your data sets will be too large. You will have thousands and 2000s of rows and columns. So if you are clear with these steps now, then it will be easy to apply into large data sets. So tell me, how is this behaving?
Ma'am, the same labels are added.
Added.
Yes.
Correct. So this is our series 4. Let's call it as series 4. We have first, then second, then third, then fourth. Okay. These are the labels. And we have values as what? 5.4, 6.1, then 99.8, 3.2. This is our S4. What is our S5? Can anybody read the values for me? Okay, S5 we have first, then third, then fourth, and then fifth. Correct? The values are what? 5.5, 1.1, 8.8, 1.6. We are trying to add this. When we try to add, how is the addition happening? The same labels are being added. That means first will add with the first in S5. The first of S4 is getting added to the first of S5. So if this is the result, the first, definitely it is going to have a label first, and the value of this label is nothing but the sum of 5.4 and 5.5. Yes. Second, you have second here. Do you have second here in S5? Do you have a second in S5?
No.
No. So second will be put as NA. That means not available. The data is of the form not available form. But second will be there into your result. But the result, in the result, the value will be NA. Now you have third. So the value of third is what? The value that is present in S4 plus the value that is present in S5. You have fourth. So fourth is what? The value of S4 plus the value of S5. You have fifth in S5, but it's not present in S4. So again, fifth will be in A. This is the result of adding two data frame. I mean the series. This is how the addition of series behaves. Is this fine? Yes?
Yes, ma'am.
Yeah. Please execute, verify it, and note down the behaviors. Now you will remember, later on you will forget. So write it down and note the behaviors. So these operations will be using on to the data sets as well. It's very common to add the two series, that is the two columns. When I say they are nothing but the series. Verified.
Yes, ma'am.
Yes, ma'am.
Okay. Next, we can combine two series. Combine, or we say we can concat two series. So when I am trying to put two series together, the result, can I call it as a data frame? Because I told you, data frame is nothing but the combination of series. Data frames are made from series. So when I'm trying to combine or concatenate the series, I'm trying to create a data frame. Can I say like that?
Yes, ma'am.
So we are going to combine the series to create a data frame. And for this, we have an inbuilt method called as concat. So if I say data frame 1, let me call this as data frame 1. So whenever you combine or concatenate two data frames, two or more data frames, keep in mind, two or more series, keep in mind that we are creating a data frame. So for this, we have the method concat. Concat as an argument within square brackets, give the names of the series that you are trying to combine. For example, let's combine this my series 4 and 5. My series 4, comma, my. Along with this, you have to give one more information. Axis. Axis equal to 1. Axis equal to 1 means it is combining the two series column by column. It first places your series 4, then beside to it, it places series 5. If my axis was 0, it would have placed the series row-wise. It would have added series 4 and below that it would have added series 5. So axis 0 is always corresponding to row and axis 1 is always corresponding to the column. So when I say axis equal to 1, it is like putting your series 4, then onto the side of that, it is placing series 5. So here on, we will see this axis parameter again. Axis 0 means it is the row. Axis 1 means it is the column. One more attribute I will add here. This we will execute and then we will say what sort equal to false is going to do. So these three parameters you have to keep in mind. Sort is okay if you're not using also, but the data series data that you are trying to concatenate, that you have to specify, and also along the axis, which axis you're trying to combine your series. That information should also be added. After this, let's check how the data frame is created. So can you see this? Can you see the difference in arranging the data as series and as your data frame? So as series, when I give the series, I had only the row indices. But see, when I put it as a data frame, I'm also getting the column indices. So column indices by default, it is 0, 1. So I have the column indices as well as the row indices. So row indices, I acquired it from the series which I have created. So first, second, third, fourth, and fifth. Now see, we are combining series 4 and series 5. So in series 4, second was present, but series 5 didn't have a index second. So the value of second in your series 5 is put as NaN. Same way, fifth is not present in your series 4. So that is being added as NaN. So when you are concatenating the two series, it takes or it considers all the row indices of both the series. So whichever value is missing, it is applied as NaN. After performing this, after verifying this, you make your axis as 0 and see the difference. After that, make the sort as true and see the difference. Is that clear? Combining or concatenating of series? Following me?
Yes, ma'am.
So please verify it. First, you verify this. After this, change axis equal to 0. Check what your output is. Then change sort to true and see your output. So what happens if your axis is 0? Can you see the difference when your axis became 0? Can you make out the difference? So this first, second, third, fourth. This was the series 4 and first, third, fourth and fifth was your series 5. Now let's make this as axis 1. If I make this as now, what can you say? How will you interpret this output?
I think the arranged in or descending order.
So normally we keep the sort as false. Now just try without using sort. So by default, sort is false. Verified? Shall I move with the next step?
Yes, ma'am.
Yes, ma'am.
Okay, so this is one way of creating your data frame, isn't it? Concatenating the series generates a data frame. Another method is by using the data frame method from the pandas. So like we created the series using series method, you have a method called as data frame using which you could create your data frames. So let's say data frame. Okay, one is already created. Let me call it as data frame 2. See, any variable names you can use. Okay, so pd dot, I will say data frame. Be careful, D and F are in capital letters. Now let's say that the data frame, let's create it from some random values. So for this, let's make use of our numpy. I will say random dot randn. Let's say 5, 5. Using the numpy arrays, we are creating the data frame. So if we display data frame 2. Can you see the arrangement of data? It's a 5 cross 5 array that we have created using the numpy, and using that array we have created our data frame. So it has the row indices as well as the column indices. By default, they are starting from 0. Now you can add labels to your rows and columns. For example, like we added labels to our series for data frame, also you can add labels. You can add labels to the rows as well as the columns. So if I say data frame 3 is equal to pd dot data frame, pd dot data frame. Let's create it from the random elements itself. So np dot random dot rand n, let it be across 5 array, and then index equal to. So this is corresponding to the row indices. You can give the row indices as a list. So let me give it like first row, second row, third row, fourth row, and fifth row. One more row I need. This index values are corresponding to the row indices. Same way, I can provide the column indices. For this, I need to add columns. Parameter columns equal to. It is columns. You have to provide it as columns. Columns equal to, and you can give the list of the column labels that whatever you want. So let me give it as first column. Then third column. Let's execute and see this. Can you see now we have labeled the row indices and column indices. So by default, they were 0, 1, 2, 3, and 4. Now we have renamed it to the rows as first row, second row, third row, fourth row, and fifth row. And columns as first column, second column, third column, fourth column, and fifth column. So please execute and see. So index, the parameter index is used for labeling the rows, and columns is used for labeling the columns. This is columns.
Done, ma'am.
Are you all following me?
Yes, ma'am.
Yes, ma'am.
Now let's see how we can access the individual series in your data frame. So when I say series in a data frame, I'm referring to individual columns of your data frame. So let's see. Accessing series in a data. For this, first I have to specify the data frame name. Let's access it from data frame 3. So data frame 3, within the square bracket, give your column name. So if I say I want to access the second column. Can you see I have accessed the second column? This particular column I have accessed, or I can say that I have accessed an individual series from my data frame. To verify.
Done, ma'am.
Okay. Suppose if you have to access multiple series, you will say df3, then the first, give the name of the data series that you want to access. Let me say I want to access the third column. Third column, comma, the next column, whichever you want to access. If I say first column. 1 second. Okay, I've not closed this. I've missed one bracket. Square bracket. So this will access the columns, third column and the first column. So if you have to access multiple series in your data frame, you'll have to go by this method.
Ma'am, it's like that nested list.
Correct. Yes.
Goes to square brackets only.
Two square brackets. Let me know if you have verified and if you are clear with accessing the series in your data frame.
Ma'am, but why? Like, if we use this one list, it's not accessing it, right? But
If you
that square brackets, if we give one square brackets, then it's not accessing.
No, you have to use this two square brackets. Within the inner square brackets, you have to provide the multiple series name. That's the syntax.
Okay.
Within the inner square brackets, you have to give the column names. Whichever columns you intend to access, you have to provide it within the inner square brackets.
Ma'am,
Hmm.
if we have to access a particular rows, then what we have
We
to
are coming to that. We are coming to that, accessing the rows.
Okay, okay, ma'am.
Have you all verified this? Clear with accessing the columns in your data frame or series in your data frame?
Yes, ma'am.
Okay. Now let's see how we can access the rows. To access the rows, we need to use a method called as LOC. That is, if I say data frame 3 dot LOC, I'm intending to access a row from the data frame DF3. Okay, DF3 of DF3.LOC, use the square brackets. Within the square brackets, give the index of the row which you are trying to access. So if I say fourth row, this will access the fourth row of my data frame. So to access rows, you need to use the method LOC. So if you have to access multiple rows, you'll have to use multiple square brackets, that is 2 square brackets. Within the inner square brackets, give the indices of the or the labels of the rows which you are trying to access. For example, if I say df3.loc, I will say which all rows. Let's say I have the first row. Comma, let me access one more row. Let's say third row. This will access the first and the third row from my data frame. So these are all accessed based upon the labels of your rows and columns. Now, this is our data frame, correct? If I say, so we have seen accessing the columns, accessing the rows. If I say df3 dot, so to access the rows, we have used LOC. Like LOC, you have something called as ILOC. If I was giving a value like this, interpret how ILOC is working. Interpret how ILOC is working. I give df3 dot ILOC. So this 2 is the index. What can you say about ILOC?
It takes third row, means
So
second
it
index.
is, yes, it is again a way of accessing your row, but by specifying the index. So if you have to give the index for accessing the row, you will have to use ILOC. If you have to access the rows through their labels, you have to use the LOC. Is that clear? So by
Ma'am,
default,
like,
all your rows and columns has the index values starting from 0. Right?
ma'am,
Uh,
that LOC has some full form or it's just LOC
it's
only?
LOC. Location. Location and
Okay, ma'am.
index location.
Okay. Done, ma'am.
Okay. So clear with data frames, series, accessing the elements of both series and data frames.
Yes, ma'am.
Okay. Now we can use logical indexing here as well, like we discussed with arrays. For example, if I say df3 greater than 0, what will be your output?
The elements greater than 0.
No, it shows like true and false. Wherever you have the relations as true, that is wherever you have the elements with value greater than 0, that will be placed as true. So this is your data frame 3. From this data frame, it is checking the relation with each and every element. Is this element greater than 0? Yes. If it is yes, it displays true. Is this element greater than 0? Yes, it's true. So wherever the relation fails, it is showing as false. Now, if I have put my statement like this, df3 off. I used square bracket. That means I'm trying to access the elements of my data frame df3. Correct? If I have given it like df3 greater than 0. Now tell me what will be your output.
Now it will take greater than 0.
Now it will pick out all the elements that are greater than 0. And the rest, that is wherever you had the false relation, that will be placed as NaN. So NaNs are those elements which are less than 0. Right? NaNs are those elements which are less than 0. Wherever you had the relationship false, they will be shown as NaNs. So please verify. So logical indexing is possible with your data frames as well.
Done, ma'am.
So this is our data frame TF3. Correct? How many columns it has? How many columns it has, the data frame DF3?
5.
5. If you want to add a 6th column, it is possible with the data frames. For this, you have to say df3 off. First, you have to access. How do we access a column? We will give the data frame name. We will use the square brackets. Within that, we will give the column label. So let's say we need the label sixth column. Assign it with the data. So when we are assigning it with data, make sure that it is related to the size of the existing data frame. Correct? So how can I initialize it here? Let me initialize this with some random values. What should be the size that I should give here? In order
5,
to add
1.
a 6, sorry?
5, 1.
Exactly. You'll have to give 5, 1, 5 rows and 1 columns. Now, if you check your data frame 3, you can see a 6th column is also added to our data frame. So this is how we add the columns to our data frame. So once you have verified this, check if you could add a row to the data frame. We have added a column. The same way you see if it is possible to add a row to the data frame. See if you could add rows to your data frame. If you have done, share the code with me. Verified? Are you able to do? Done? Sanket, done? Neha, Disha, what are your
No,
status?
no, madam.
Okay. So to add, first what you have to do? You need to access. So suppose if it is from the data frame 3, you'll have to say df3 dot, it's a row that we are going to access. So you will use LOC. Give your row label, whatever it is. Let's say sixth row, whatever it is, okay? Any label. Now you have to assign it with value. So how many values we need here? You will need the row size is what? 1. That means basically you are initializing this with a vector, right? You will have one row, and what is the column size? We have added 6 columns. So you will need to initialize this with a vector of 1 cross 6. Correct or not? Yes. So if you are initializing it with some random values, you could say np dot random dot rand n of 6. Isn't it? This will create random of 6 will create what? A vector with one row and column size as 6. Yes, following me?
Yes, ma'am.
Yeah, so please try it.
Yes, done, ma'am.
Oh. So like you add a row or column, you can remove them. You can remove your columns or rows. So for this, we use a method called as drop. So df3 dot drop. Let's say we want the column to be removed. And let's say the first column is the one that we want to remove. Since it's a column, I will say axis equal to 1. Now see, I'm performing this. Okay, so now you could see the df3.drop. The result is what? The first column which is removed. The result of this operation is a data frame with the first column being removed. But if I check my original data frame, you could still see the presence of first column. Are you following me? When I used df3.drop, the result of this operation was removing the first column from my data frame. But my original data frame still contains the first column. Correct? Correct?
Yes, ma'am.
So if this result wants to be reflected onto your original data frame, that means the result if you want to reflect it onto your original data frame, or if you have to remove this first column from your original data frame, then you have to add one more parameter called as in place. Say in place equal to true. Then this change will be reflected onto the original data frame. So now if I repeat this, and then if I display my df3, can you see this is my original data frame? My first column is being removed from the original data frame. It's because of this parameter in place. I have made in place as true. So the result of this operation will be reflected onto my original data frame. If you don't want it to be reflecting it onto the original data frame, please don't use the in place parameter. If you want the result to be reflected onto your original data frame, that means if you have to remove the column from the original data frame, use this parameter in place, make it as true. Clear? Yes?
Yes,
Yes, ma'am.
Yeah. So verify this and remove a row from your data frame. After verifying this, remove a row from your data frame. No, Namrata. You'll have to add one more parameter here. You have to make changes to the axis. Put your axis as 0. Axis 0 refers to your row. So after giving the row label, put axis equal to 0 as well. Fine, Pranav.
Ma'am, it also works without access.
But that will not work every time. It will give you unexpected behavior sometimes. So it's good to explicitly specify what your access is.
Okay, ma'am.
Yes, Nedra, fine. So I hope all are able to drop the rows as well.
Yes, ma'am.
Okay. Now let's try something else. If I say df3 dot reset underscore index. What can you tell about the output? How will you interpret this output? Reset index.
It removed the labels from the index.
Yes, the index labels are being removed. Or it added the default indices. So please verify. So again here, if this change has to be reflected onto your original data set, you can use the in place parameter here as well. If you say in place equal to true. Then if you check your data frame 3, this change is being reflected onto your original data frame.
Done, ma'am.
Verified?
Yes.
Yes, ma'am.
So like you reset your index, you can set the index value. For this, let's say we are adding a new row. Let me call this as new index. Okay, new index equal to, let me assign this with a vector. Let's say 1. 2, 3. How many I want? 1, 2, 3, 4, 5. Oh, sorry, it's df3. Now if I say df3 dot set index, I'll say this. I want the new index to be given as the new index labels, and then let the change be reflected onto the original data set. Can you see? Now my index labels are set as 1, 2, 3, 4, 5, and 6. So earlier when I reset it, the indices was 0, 1, 2, 3, 4, 5. This is now set to the new index labels or index whatever I have used, 1, 2, 3, 4, 5, and 6. So this is how you reset and set the index values, index labels.
Done, ma'am.
So clear with data frames and series, whatever we have discussed up to now. Creating, accessing, adding, removing, setting the index value, resetting the index values. Fine?
Yes, ma'am.
Yes, ma'am.
Next is combining of the data frame. So that we will discuss in tomorrow's session. Fine?
Yes, ma'am.
Okay, guys. So then let's break for the day. We will discuss further in tomorrow's session. So please practice this. Now when you're hearing, it is easy for you to do it, but you will forget it soon. So practice it, okay? Which all functions to use, what are the syntaxes, etc., etc. Right? So please practice. More about the same we'll discuss in the next session. Okay?
Yes, ma'am.
Okay, guys. So bye-bye all. Take care.
Bye, ma'am.
Yeah, bye.